All right, welcome back, everyone. Today, we're unlocking something absolutely crucial for your Cambridge 0580 mathematics exam. We're breaking down percentages. But look, forget thinking about this as just some abstract math hurdle. We're building a practical, mental toolbox today. Whether you're quickly calculating a discount, managing personal finance, or, most importantly, hunting for those top marks on your IGCSEs, this explainer is your ultimate cheat code. Let's get right into it. Here is the roadmap for our session. We're starting with the percentage foundation, then calculating percentage quantities, and hitting real-world percentage change. From there, we unlock the multiplier shortcut, which is huge, then finding original quantities, and finally, we take on the final boss, simple versus compound interest. Okay, section 1, the percentage foundation. Every high-level exam question basically relies on this foundation. Nail this part, and you are already halfway there. So, what is a percentage really? Well, it's literally in the name. Percent means out of 100. Anytime you see that percentage sign, you're just looking at a fraction where the denominator, the bottom number, is exactly 100. It's just a standardized way to make comparing different numbers super easy. For example, let's think about 13%. That is literally just 13 out of 100. If you punch 13 divided by 100 into your calculator, or, just slide that decimal point 2 spots to the left, you get 0.13. It's the exact same value, just dressed a little differently. Think about how interconnected this all is. Percentages, fractions, and decimals. They're just 3 different dialects of the same math language. 13% is 13 over 100, which is 0.13. Look at 5%. That's 5 over 100. Simplify it down, you get 1 over 20, or 0.05. Being able to switch between these 3 effortlessly, that's the very first tool in your toolbox. Moving along to section 2, calculating percentage quantities. Now we are putting these concepts to work. These are the hammer and wrench of your mental toolkit. Oh, and before we continue building this out, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. A super common exam task is expressing one quantity as a percentage of another. There's a foolproof way to do this. First, set up a fraction. Your first quantity goes on top as the numerator, and the second quantity is your denominator on the bottom. Once you've got that fraction, just multiply the whole thing by 100. Boom, you've got your percentage. But what if you're stuck in a non-calculator paper? Say you need 15% of $240. You might panic, but don't. There's a brilliant mental strategy for this. Break it down. First, find 10% of 240. That's easy, just chop off the 0, right? You get 24. Then, 5% is exactly half of 10%, so half of 24 is 12. Finally, just add them up. 24 plus 12 equals 36. It's quick, it's painless, and it secures the marks. All right, section 3, real-world percentage change. This is where we step out of the abstract and actually apply it. We're talking profit, loss, and calculating value shifts, which the exam boards absolutely love to test you on. Picture this classic scenario. We all know how fast tech depreciates, right? So if the value of a computer drops from $1,200 down to $700 in a single year, what exactly is the percentage decrease? Let's run the formula. Step 1, find the actual change in value. $1,200 minus $700 is $500. Step 2, and listen closely because this is where everyone drops marks, divide that change by the original amount. Always the original, never the new one. So 500 divided by the original 1,200. Step 3, multiply by 100. That gives us a pretty brutal 41.7% drop in value. Okay, on to section 4, the multiplier shortcut. This right here is what separates the top-tier A-star students from the rest. It's all about efficiency. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's apply this cheat code to a real problem. Amir has a salary of $17,000 and gets a 3% raise. The slow, traditional way? Find 3% of $17,000, write it down, then add it back to the original. 2 steps. Too slow. We can find the new salary in one single move. The secret weapon is the multiplier, 1.03. follow the logic here. Amir starts with his whole salary, which is 100%. He gets a 3% increase, so his new salary is literally 103% of what he used to make. And remember our translation rules. 103% as a decimal is 1.03. So you just do 17,000 multiplied by 1.03, and bam, you land straight on the final answer of $17,510. One step. It is a massive time saver on the exam. So let's flip that logic for section 5, finding original quantities. I like to call this the mathematical time machine. We're going to use reverse percentages to rewind time and figure out what a number was before a change even happened. Check out this setup. In a sale, everything is marked down by 10%. Selma buys a dress for $38.70. The exam question wants to know, what was the original price before the sale? We have to think backwards. Here's how you use the time machine. Step 1. Identify your multiplier. A 10% discount means she paid 90% of the original price. 90% as a decimal is 0.90. Step 2. Take the new price, that $38.70. Now, if multiplying pushes us forward to a new price, dividing pulls us backward to the original. So step 3, divide $38.70 by 0.90. That drops us perfectly back at the original starting price of $43. All right, we made it to section 6, Simple V's compound interest. Your toolbox is fully loaded now, so let's pit these two financial heavyweights against each other. There's a super clear line between these two. Simple interest is flat. It is calculated only on your starting amount. If you earn $200 in interest the first year, you earn exactly $200 the next year and the year after that. But compound interest? That's dynamic. Your interest gets added to the pot. So the next year, you're earning interest on your interest. It snowballs. Because compound interest snowballs, calculating it year by year is a total nightmare. Enter the formula. A equals P times 1 plus R over 100, all to the power of N. I know it looks intimidating, but it's literally just our multiplier trick. P's the principal, your starting cash. The stuff in the brackets, that's just your interest rate R turning into a decimal multiplier. And N is just the time, how many years you are compounding it. Let's test it with Salim's dilemma. Salim is investing $4,000 for exactly 5 years. The bank gives him an option, a higher rate of 3.5%, but it's simple interest, or a lower rate of 3.25%, but it's compound interest. Instinct says compound is better, right? But that simple rate is undeniably higher, so who actually wins? This is exactly why you always run the numbers. Over this specific short 5-year window, the 3.5% simple interest actually gives him $4,700. The 3.25% compound interest, only $4,693.65. The simple interest actually beat the snowball by $6.35. Why? Because 5 years just wasn't quite enough time for the compound effect to overtake the higher flat rate. Okay, let's recap the toolbox. 1. Percentages are just fractions out of 100. 2. For percentage change, always divide by the original amount. 3. Use those multipliers to cheat time on your exams. And 4. Master that compound interest formula. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our content. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at @ace_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ace_IGCSE and click that bell. Don't let another exam pass you by. I'm going to leave you with this. Salim's simple interest won over 5 years. But what if you left $1,000 in the bank for 50 years? How much of a difference do you think that compounding snowball makes compared to a flat rate over half a century? The gap is absolutely staggering. Grab a calculator, run the formula, and see for yourself. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this explainer with a study partner. Ace the Exams, your Cambridge success starts here.